So if at the maximum height, the final velocity v is equal to 0, then using equation 1, we'll have 0 is equal to u minus gt. And when we make t the subject, we have gt equal to u. T therefore equals u over g. And this we said is the equation for the time taken to reach the maximum height. So time taken to reach the maximum height. Then we want an expression for the maximum height itself. Equation for the maximum height itself. In determining equation for the maximum height, we can use equation 2 or 3. Let's use equation 3. Then we explain using equation 2. At the maximum height, v is 0. So v squared is equal to u squared minus 2gh. 2gh is equal to u squared. Therefore, when we make h the subject, we have h equals u squared over 2g. And this is the equation for the maximum height reached. Maximum height reached. We'll be solving questions, so we'll see how to use them. The same thing, it can also be derived using h is equal to ut, where t is the time taken to reach the maximum height, which is u over g, minus 2 half minus half j times u over g. And we went through this and then saw that this will give us u squared over g minus half u squared over g. We subtracted and got the same thing as u squared over 2g. Okay, so this is the two standard equations, the equations of motion, the standard equation for vertically upward motion when the object is projected vertically upward. Today, let's look at when the object is projected downward from up and falls to the ground. What happens? Any question before we move on to vertically downward motion? This is for vertically upward. Giovanni.
Please, I thought the second.
Giovanni, I'm listening.
Sir, please, I was asking if the second equation can be used for the maximum height reached.
Oh, that is the same thing I used here. I use this equation too, this one. This is what I've used in deriving the maximum height here. So h equals ut minus half gt squared. Then you substitute the time taken to reach the maximum height for t. So that's exactly what I've done. Are you okay?
Yes, sir.
Okay, so straight away, for vertically downward motion, vertically downward Downward motion. So class, the difference here is that this time around we have an object up. The ground is here. There an object here. Either it can be a mango hanging on a tree or a coconut hang on a stalk. Then falling to the ground. This is the vertical height from where the object hangs to the ground. Of course, this is the ground or the earth surface. So the object is here and it is falling through a height h. At where the object hangs, the initial velocity of the object is 0. At where the object hangs, in this particular context, the initial velocity of the object is 0. Now, as the object falls, its speed will be increasing. So as objects falls, its speed will increase. And I want somebody to tell us why is there an increase in the object speed whilst it falls? Yes, please, you can go ahead and answer.
Because the force of gravity will be acting on it.
So, yes, thank you. So as the object falls, its speed will increase due to gravity. So when an object falls from a height, as the object drops to the ground, its speed increases as due to force of gravity. Class, are we okay?
Yes, please.
And the body is then said to be, said to be free falling. Said to be free falling. Free falling. So when an object is said to be free falling, a free falling object, okay, falls, a free falling object falls when gravity is the only force, acting on the body. Jesse, please mute yourself for me. Acting on the body in the absence of all other forces such as friction and air resistance. So please, that's the definition of free falling. When a body is said to be free falling, then gravity is the only force that acts on the body in the absence of all other forces, such as friction and air resistance. So when a body is dropped from a height to fall to the ground, the body can be free falling. When the body is in falls freely, its initial velocity is equal to 0. A free falling object is accelerated by gravity, force of gravity.
Water.
A free falling object is accelerated by the force of gravity or gravitational force. And falls with a constant or uniform acceleration of 9.8 meter per second squared. Please do not write on my board. Please, if you have any question, ask. So for a free falling body, it is accelerated by force of gravity and falls with a uniform or constant acceleration value of 9.8 meter per second squared, which sometimes is approximated as 10 meter per second squared. For a free falling body, Jessica, please mute yourself for me. For a free falling body, its velocity time graph. When you plot a graph of velocity against time, velocity against time, you have Jaidin, mute yourself. Its velocity time graph is like this. For a free falling body, its velocity time graph looks like this. Then the slope of this graph for a free falling body, which is equal to the change in vertical against the horizontal the slope is equal to delta V delta T. This slope is equal to delta V on delta T is equal to 9.8 meter per second squared. So for a free falling body, its velocity time graph is equal to the acceleration due to gravity. Asida and Co, are you there? So the velocity time graph for a free falling body, the slope of such motion would give you the acceleration due to gravity. If you have any question, ask before we continue. Or I take attendance. Please give me a minute to take attendance. Okay. So that's the slope of the velocity time graph for a free falling body. For a free falling body, the slope is equal to. I'll be with you very soon. Hey, Frank, I'm listening.
Please, how is the constant acceleration 9.8 meter per second square when the object can be heavier or lighter?
Good. It's a good question you've asked. I'll explain. Okay. Okay, good. Emelda, your question.
Please, can you repeat what you said about the velocity time graph of a free falling object?
Okay, so I said that for a free falling object or body, a graph, its velocity time graph, okay, is this. Will give you a straight line starting from the origin. It is starting from the origin because the initial velocity u is 0. Okay, and it will give you this straight line. When you take the slope of a velocity time graph for a free falling body, the slope is equal to the uniform acceleration due to gravity, which is 9.8 meter per second squared, irrespective, because of Frank's question, irrespective of the mass of the body. Meaning it doesn't matter whether the mass is as big as whatever or small. They will all be accelerated by the same value, which is 9.8 meter per second squared. Frank, you see, when an object hello, Imelda, have I
This
answered?
is a uniformly accelerated motion over time instead of velocity.
No, this is velocity time graph for a free falling body.
Okay.
So you can take it as a uniformly accelerated motion because the slope which represents the acceleration due to gravity is the same along the line, the graph. Okay. So this can also be a uniformly accelerated motion for a free falling body or object. Emma, are you fine?
Yes, please.
Frank, you see, when an object is dropped at a height, two objects of different masses are dropped from a height, and we have factors such as air resistance is not or is neglected. So where you have air resistance very, very small, or neglected, no matter the size of the object, they are all expected to drop on the ground at the same time. This is because they will all be accelerated by this constant value of 9.8 meters per second, meaning that at every 1 second, the body travels with a speed of 9.8 meters per second. Okay, so the earlier physicists, such as Galileo conducted this experiment by standing on a tower in Greece. I think he dropped a coin and a hammer, and because air resistance was not there, they all landed at the same time on the ground. Then Neil Armstrong also conducted the same experiment on the moon using, I think, a hammer and a coin. And even on the moon, where air resistance was seen to be negligible, the coin and then the hammer dropped or landed on the ground at the same time. So when an object, two different objects of different masses are dropped, in the absence of all other forces such as friction and air resistance, they all fall equally with the same velocity, and it doesn't matter the size or the mass of the object. They must all drop to the ground at the same time, and this is free falling. And don't forget, the condition is that for free falling, air resistance and all other forces must be eliminated, and only force of gravity must act on the object. And when we have that, they will all fall at the same speed and at the same time on the surface of the earth. Frank, are you okay?
Yes, please.
All right. Please, is there any other question before we move to vertically downward motion equations? Okay, so let's derive the equations. For a vertically downward motion. Now, for free falling body, Priscilla, are you here?
Yes, sir.
For free falling objects or body, the initial velocity u is equal to 0. The initial velocity u is equal to 0. So, using the three equations of motion, v is equal to u plus at. For vertically downward motion, this becomes v is equal to u, but u is 0. So 0 plus. Now this time, the bodies falling to the ground would accelerate, meaning the speed would increase. And I just said that for free falling body, its speed increases by 9.8 meters per second for every 1 second. Meaning, for 1 second, Frank, I'm coming. 1 second, the speed will be 9.8 meters per second. For 2 seconds, the speed will be 9.8 times 2. For 3 seconds, the speed will increase by 9.8 by 3. For 4 seconds, so As the object drops, the body speed increases in equal rates within equal time interval. Frank, your question.
It was a mistake.
Okay. So we have V is equal to 0 plus gt. And this is a plus because body accelerates as it falls. Body accelerates. But this acceleration is due to gravity. So it is a positive gene because it's an acceleration. Then the second equation would also be S, which is equal to ut plus half at squared. And this will be equal to h equals ut plus half jt squared. And because u is 0, we'll have a half j t squared. This is the equation for the height, vertical height range at any time t. Don't forget, j is constant. So h, it means that v is only directly proportional to t because j is a constant. And h is also directly proportional to the square of t because half and j are constant. Plus, are you there? Anita, are you there?
Yes, sir.
All right. Giovanni,
Can you go over again?
let me finish with the third one and then the last equation, which is in linear motion, this is v squared is equal to u squared plus 2as. Here it will be equal to v squared equals 0, u is 0, plus 2jh. So you can use this. V will be equal to square root of 2jh. You can use this to find the velocity after any vertical height h. All right. So for vertically downward motions, the three equations are for a vertically downward motion, and for that matter, for a free falling body. So for a free falling body, u is equal to 0. Then the first equation becomes v is equal to 0 plus gt, which in effect is equal to gt. So this is the first equation for a free falling body. The second equation, h is equal to ut plus half jt squared. And because u is 0, we'll have h will be equal to half jt squared. And then the third equation, v squared is equal to u squared plus 2jh, which is equal to 2jh, and v will be equal to square root of 2gh. So these are the three equations for vertically downward motion, which is actually free falling, when gravity is the only force acting on the body. Now, there can also be a situation where an object falls to the ground, but not due to gravity, or when there is another force. When there is another force aside gravity, when there is another force acting on the body. So when gravity is the only force acting on the body is said to be free falling. When there is another force, and I'm going to give example. We have Frank and Giovanni. Frank and Giovanni are given 2 oranges to drop to the ground from the top of a story building. Now, Antoinette, please mute yourself for me. Giovanni drop his. Antoinette. Okay. Let me mute all. Giovanni, your hand is up. Why? So this is Giovanni's orange. And then this is Frank's orange, the same mass. Now, Giovanni decided to let his fall freely. So once Giovanni's is free falling, it means the initial velocity is 0. Frank applies a force on the orange downwards, and it gives it a certain initial velocity u. Now, look at the 2 scenarios: Giovanni's orange and then Frank's orange. Which one will drop on the ground at a faster time or at a lesser time?
Sir, please come again.
Giovanni.
Sir, please, Frank's own will drop first.
Frank is no stone, orange.
His orange will drop first.
Why do you think so?
Because Frank's orange, there was an additional force that was added to it.
Aside gravity. Good.
Yes, please.
Good. So when you have 2 stones or orange, okay, thrown from the same height to the ground, and one is let fall freely. This is free falling, and the other one has a certain initial velocity. There's a force given to it. So we have a certain initial velocity. This one will drop to the ground, okay, at a lesser time than this. Here, this will accelerate due to gravity, and this will accelerate due to the force. So, if you want to derive an equation for Frank's fall, the first equation will be equal to u plus jt. This time u is not 0. U is not 0. Let me bring it here. V will be equal to U plus GT. And in the case of free-falling body, for a free-falling body, the velocity at any time t will be equal to GT. So you realize that this will be greater than this one. Then the second equation, as h would be equal to half GT squared. That of Frank would also be h is equal to ut plus half GT squared. So h will be greater because of this ut. In the case of free falling, this part is 0. Then v would also be, v squared will be equal to 2jh. Here v squared would be equal to u squared plus 2jh. So this is the difference between when the body is free falling and when the falling body is acted on by another external force. Please, are we okay?
Yes, please.
Any question? Giovanni,
The H surface, is it for the height that it is falling from?
vertical height reached.
So sir, can you use it to calculate for the maximum height reached?
Oh, we are going to solve a problem. So no fears. Are you okay?
And sir, please, if there are two objects falling from a distance and one is heavier, won't it fall faster than 10 meters per second squared?
No, I said in the absence of all other forces acting on the two objects, it doesn't matter the mass or the weight of the object. That is why Neil Armstrong went to the moon, dropped a coin and a hammer. And because air resistance was neglected, he observed that they all dropped at the same time. So when air resistance and all other forces are not there, they must all drop at the same time, irrespective of the mass or the weight. That is for free-falling bodies. But if one is given a force and the other one is not, no. Okay, Frank.
You said Neil Armstrong dropped a coin and a hammer on the moon.
Yes.
They all fell at the same time.
Yes.
But at that time, there wasn't any gravity acting on it. So how is it considered a free fall?
There is a gravity on the moon, but very, very small. I think gravity on the moon is has a value of acceleration due to gravity on the moon is 1.6 meter per second squared, whereas on the earth is around 9.8 meter per second. So there's small level of gravity on the moon.
And also, in what instance is air resistance absent?
So you cannot eliminate air. So around us, okay, where you must wait or conduct the experiment when air isn't, wind is not blowing. Okay, so you can eliminate or neglect air resistance when you realize that there's no wind blow or wind movement. That is neglecting or avoiding air resistance. Imelda.
So when you're comparing two free-falling object. It doesn't matter the mass.
Yes, they must all drop at the same time, so long as it is free falling.
Okay.
Frank, are you okay?
Yes, please.
All right, so let's test all that we've learned by solving problems with them. I'm going to give you a question to apply what we have actually gone through today. Are you ready? Are you there?
Yes, please.
Okay. So question 1. A book falls from
Please, I can't hear you.
a book falls from a height. A book falls from a I'm coming. Let me take attendance again. I'm coming here. A quick one. A book falls from a height 2 meters above the floor. A book falls from a height 2 meters above the floor.
Sir, please pause from my height.
2 meters above the floor. I'm coming. Just give me a minute. So a book falls from a height 2 meters above the floor. At what speed does it hit the floor? At what speed does it hit the floor? That's the first question. Then the second question. A stone is dropped from a cliff. A stone is dropped from a cliff. From a cliff 70 meters above the floor. A stone is dropped from a cliff 70 meters above the. Did I say above the floor?
Please,
Yes,
can you start?
please.
Let me take that again. A stone is dropped from a cliff 70 meters above the sea. Above the sea. How long is the stone in the air before it hits the sea? A stone is dropped from a cliff 70 meters above the sea. How long is the stone in the air before it hits the sea? So 2 questions. Let's look at it together. So question 1. Question 1. A book falls from a height 2 meters above the floor. So let's produce a quick sketch. This is the floor. The vertical height from the floor this is the position of the book. And we are told this is 2 meters above the floor. At what speed does it hit the floor? At what speed does it hit the floor? So we are looking at the speed just before the book hits the floor. So speed V just before it hits the floor. This is crucial because you see, when the book hits the floor, the final velocity becomes 0. So usually in determining the speed, we are looking at the speed just before the book hits the floor. So can you make me proud? This is vertical downward motion. So V is equal to JT because U is 0. V squared equals 2JH. And H equals half JT squared. These are equations, the equations to use in solving this problem. So clearly, once we have J, take J, let's take J to be 9.8 meter per second squared. It means that using this equation, V just before it hits touches will be square root of 2 times 9.8 times 2. So we have almost approximately 400. Approximately 400. So the speed must be a little, either 19.9 something or 20 meter per second. I am presuming that J is 10. So get the actual value and give me the value of V. What did you get for V? Plus, what have you had for V? If you use the actual value. Giovanni, are you there?
Yes, sir.
And what's your actual value?
Sir, 98.
I'm coming on. What I'm saying, 2 times 9.8 times 2. This is, oh, okay, it's not 400, it's 40. It's 40, sorry, please. This is 40. So if you take it even as Priscilla,
Sir, the point is 39.2, so I think it will be 39, not 40.
I get you, but no, what I'm saying is that I'm only presuming that J is 10. So before we come out with it, I'm just trying to figure out something. Okay.
Okay.
So what's the square root of 39.2? Gideon, go ahead.
76.26.
Okay. So this will be the velocity just before it hits, okay, on the floor. And you can also use this. You can also use equation 1. V is equal to gt, but if you use equation 1, you must find t to multiply by g. And somebody else can decide to use equation 2 to find t. Half j t squared. H is equal to 2. J is 9.8. This is t squared. So we have t squared equal to 4 divided by 9.8. And what is 4 divided by 9.8? This is 0.4082.
408.
So that's the square root of this. Give me the square root of 0.4. I'm waiting on 0.4082.
0.6.
0.6388.
0.6389 seconds. Okay, so that you can then use this to, if J is 9.8 and T is 0.6389, then V will be equal to almost 6.26. This is 6.261 meter per second. So the other way out to also do, but Charlie, we are always trying to use time wisely so that we can actually make the time for other questions. So please, you use the equation which will take you there direct and do not beat about the bush. Is that okay, class? Okay, the next question is for you. Okay, Augustina. The next question is for you.
There.
Hello.
So please, we use the 9.8 instead of the 10.
Acceleration due to gravity, whichever values to that is expected to be used will be given to you in a question. Okay.
Okay.
Or you don't worry. If it's not given, you are free to take 10 or 9.8. Yes, I want you to attempt the second question. A stone is dropped from Sorry. Okay. A stone is dropped from a height or a cliff 70 meters above the sea. How long does the stone, or yeah, does it take the stone to? How long is the stone in the air before it hits the sea? Okay, so Gideon, are you done?
Okay. For the acceleration due to gravity, are you sure?
Come again.
For the acceleration due to gravity, are you sure? So my time was 7 seconds.
Okay, so Giovanni, what's your answer to?
Yes, I got 3.74 seconds.
3.74 seconds. Okay, let's wait for the rest to also give it a try, then we'll discuss. Okay. Either let's hear from you as well. Akosia, Augustine, Barak, Hafiz, Caleb, Pujo, Anita, Anna, and the rest of you. Let me hear from you. Okay. Giovanni, is your hand up again? So the vertical height of the cliff is 70. Priscilla, are you done?
Yes, sir.
What's your answer?
3.8 seconds.
We shall see. So use acceleration due to gravity of 10, okay? cm, and then our G value is 10.
Yeah.
Hello.
Sir, sorry, 3.7 rather.
Okay. We are looking how long is a stone in the air before it hits the sea. Okay. Gideon, let's see.
The answer is 3.7 seconds.
Mate. So if this is what I'm using, H is 70 times J value is 10 times T squared. So this is 5. So I have 5T squared equals 70. Divide through by 5. T squared is equal to 14. T is the square root of 14. And what's the square root of 14? It must be 3 point something, because square root of 16 is 4. So this must be 3 points. 3 points.
744.
744.
3.74142.
So seconds. Please, so this will be the time the stone would take before it drops into the sea. Please, any question if you are not clear with something? Frank.
You said that this time we didn't use the 9.8.
Oh, you see, it's just a choice. I can decide to use 9.8, but this value of gravity in exams, it will be given to you. Whether 9.8 or 10, they will state it. Okay. Asida,
Please,
Asida, speak up.
can you only use when I use the other formula, the formula you used first?
Okay, so let's try the other formula. We are looking for the time it would take the stone to hit. So I can decide to find velocity just before it drops into the sea and then use it to find the time. So using V is equal to GT. T would be equal to V over G. So if I use V squared equals 2JH, I have H. H is 70. So square root of 2 times my G value is 10 times 70. So put them together for me. This is 14, 2 zeros, 0, 0. So V is equal to, what's the square root of 1,400? What's the square root of 1,400?
That's 7.417.
That's 7.417 meter per second. Good. Therefore, T will be equal to 37.417 divided by 10, which will be 3.7417 seconds. Okay. Approximately 3.742 seconds as we got here. So as that the value is still the same. Is that okay?
Okay, thank you.
All right. So let's look at the other theories. An object is thrown from the ground to a vertical height, vertically upward from the ground. The object traveled with a velocity u, initial velocity.
Sir, please have rewrite.
No, I'm just, don't write, I'm coming.
Sir,
Hello. Priscilla, I'm not asking you to write.
I was asking.
No, don't write.
Okay.
So this is the object. It is thrown to go up. With a certain initial velocity u. This is the part of the object. It goes here, gets to a maximum height, and then falls back to the ground. Pam, abelande. The maximum height of the object is this. The maximum height the object traveled is this. This vertical height. So H maximum. We are to look for certain information. One, H max we are to determine maximum height reached and the time taken to reach the maximum height, T max, and then the time of flight, T of flight. We've understood H max. H max is when it was thrown from the ground, the maximum height it reached. So from the ground to this point is the maximum height. This is because at the maximum height, what happens there? At the maximum height, what's the condition there, class?
The object begins to accelerate.
No. At the maximum height, what happens?
The velocity is 0.
The final velocity is 0. So that is why it will return back. So we've seen that for H max would always be equal to U squared over 2G, as we've seen. Then the time taken to reach the maximum height would be equal to U over G. What is the time of flight? The time of flight is the total time used during the whole flight of the body. The total time taken during the body's flight. What do we mean by flight? The motion started from here, moved, got to the maximum height, and then dropped to the ground again. So this is the whole flight. The shape represents the flight of the body. So time of flight is the total time taken during the whole motion of the body, from moving from the ground, reaching the maximum height and falling back. So if the body takes T max to move from this point to the maximum height, then it will take the same height to move from the maximum height to drop to the ground. So time of flight, TF, is always equal to 2 times the time taken to reach the maximum height. This is moving from the ground, going up and then dropping to the ground. So from ground to ground, for ground to ground, time of flight would be equal to 2 times the time taken to reach the maximum height, which is U over G. And so 2U over G. Or if we took the body 2 seconds to move from the ground to reach the maximum height, then it will also take the same time to move from the maximum height to the ground. So the total time of flight will be equal to 4 seconds. Class, are you with me?
Say,
Hello.
please, the time of flight. You said it's ground to ground. That's the time of flight.
For ground to ground, for this particular context, and the context is the body moved from the ground and dropped to the ground. So for ground to ground, are you okay?
Okay.
Then the time of flight will be 2 times the time taken to reach the maximum height. So if it took 2 seconds to move from the ground to the maximum height, then it will also take 2 seconds to move from the maximum height to the ground. Frank, your hand is up.
Please, so if an object doesn't fall at where it was thrown from, does that mean that the it didn't have a vertically like uniform velocity.
No, it's you see, this consideration is for ground to ground. I'll look at other considerations. That is why I said for ground to ground. I will look at this, talk about the other considerations. Okay.
Yes, okay, okay.
Now, for ground to ground, what will be the total height or yes, the total height travel? H total or maximum distance travel. For ground to ground, what do you think will be the maximum distance or the total distance travel? Total distance travel. Yes. Anybody? Imelda, Anita, Alcida, what will be the total distance traveled in this case? Hey, everybody is quiet. Oh, the body, Frank.
The total distance would be two times the distance from ground to the final velocity.
Exactly. So you see, it will move from the ground and then go up. And then we'll also move from the where the final velocity is 0 to drop to the ground. So if it took 10, it will go through 10. So 2 times the maximum height. Okay. All right. A question. A question. A stone is thrown upwards. A stone is thrown upwards with a speed of 20 meters per second. So the initial speed of the stone is 20 meters per second. It's 20 meters per second. Find the time the stone takes. Hold on. Find the length of time the stone is above a height 10 meters. Find the length of time the stone is above a height 10 meters. Rempoma,
Sir, please, can you repeat the question
so
again?
a stone is thrown upwards with a speed of 20 meters per second. Find the length of time, the length find the length of time the stone is above a height 10 meters. A height 10 meters. If the stone is thrown from ground level, find the length of time the stone is above a height 10 meters. If the stone is thrown from ground level. If the stone is thrown from 2 meters above ground level. Find the length of time the stone is above a height 10 meters if the stone is thrown from the ground level.
But we will is no longer campus now.
Yeah,
The personator of our room, the credit officer, credit risk officer, and friend. Also, there our campus is here for marketing department. I have about to go to.
Okay, so if the stone is thrown from ground level, and if the stone is thrown from 2 meters above ground level. Giovanni,
Please, did you say find the length or find the time?
find the length of time, the magnitude of time. The length of time. Okay? Or the amount of time. Yes, go ahead and ask your question.
So, sir, what the question is asking we should find is that we should find for how long the stone was above the 10 meters.
Yes, find the amount of time or the time if the stone is thrown from the ground level. Okay. Then if the stone is thrown from 2 meters above the ground level. So just think through. I'll also guide it. I want to see how you can analyze the question and then produce an answer. So a stone is thrown upwards with a speed 20 meters per second. Find the length of time the stone is above a height. First, the height is if, so in the first case, if the stone is thrown from the ground. So if it is thrown from the ground, this is the stone. So from the ground to the stone, where the stone is, we are told is 10 meters. Then if it is thrown, if the stone is thrown from 2 meters above the ground, okay, so we have, this is the ground. This is meaning the person doing the throwing is standing on something. And that thing is as a height which is 2 meters above the ground. That's the ground. And the stone is thrown. So if the stone is here, okay, and I don't want to finish this for you. I've given you a consideration. So Let's see what you can be able to produce. So what's the answer for the first question? Yes, what's your answer? 26.
20
Okay. Any more view? Yes, any more view? Okay, so we are looking for the time. Yeah, Giovanni,
There's a 2 seconds.
you had 2. Okay, so H is equal to UT plus half JT squared, or V is equal to U, hello,
Yes, Mike.
okay. So we can use, for time, we can either use this or that, okay. This object has a height 10 meters above the ground. So 10 is equal to U20 T plus half. Let's use 10 for T, for gravity. So you have 5. So we have 5 T squared plus 20T minus 10 is equal to 0. Therefore, T squared plus 4T minus 2 is equal to 0. All right. Please, is that what you got?
Yes.
Okay. So how do you factorize this? We can use this factorization method unless we use almighty. T is equal to minus B plus or minus root of B squared minus 4AC, all divided by 2A. My B is equal to minus 4 plus or minus root of 4 squared is 16 minus 4 times A is 1, C is negative 2, all divided by 2. So our T is equal to negative 4. Oh, hold on. Let me clear this space and use. So negative 4 plus or minus square root of, this is 16 plus 8 divided by 2. We are not interested in the negative because there is no negative time. So minus 4 plus square root of, what's the square root of 24? Class, give me the square root of 24. But
4.8.
what's the square root of 24?
4.8.
Your line is breaking on. Hey, Abusha,
4.889.
4.898. All divided by 2. So this is giving us 0.898 divided by 2. And our answer, divide 0.898 by 2. This is 0.449 seconds.
49.
So it would take the stone this time to travel 10 meters from the ground. Imelda,
Sir, please, I don't understand.
which one?
From where you got the 5t squared plus 20t minus 10 equal to 0.
Mate. So we use this. Let me go over quickly. We use H is equal to UT. We are moving up. So minus half JT squared. And the vertical height from the ground is 10. U is 20. We don't know T. Gravity, acceleration due to gravity is 10. So if we simplify this, we have 20t minus 5t squared. And we want to represent this as a quadratic expression. So I'm equating everything to 0. But I want to change this to be positive. So when this crosses the equal to sign, we have when 5t squared and 20t crosses, we have positive 5t squared, negative 20t, okay, plus 10 is equal to 0. When we divide through by 5, because all the coefficients are divisible by 5. So we have t squared minus 4t plus 2 is equal to 0. Class, are you okay here? Imelda and the rest of you, are you okay with this equation, how we got this?
Yes, please.
Yes, please.
Now, at this section, we must factorize this quadratic expression. But there's no way we can do this, okay, unless we use almighty quadratic equation. The almighty quadratic equation, okay, is taken from the general quadratic equation formula, which is ax squared plus bx plus c is equal to 0. So I'm comparing this equation in the rectangular block to this. When you compare, my x squared is actually t squared. So it means whatever is here is equal to what is here. So what we have is t squared minus 4t plus 2 is equal to 0. T is equal to x. So a here is equal to 1. There's number 1 here, but we don't usually write it. And B here is equal to negative 4. So B is equal to negative 4. And C is equal to 2, positive 2. That is how we compare. So whenever you have a quadratic equation and it is not easily to be factorized, you use the almighty quadratic equation formula. The quadratic equation formula. And that is the quadratic equation formula is equal to x is equal to negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. So whenever you have a quadratic equation formula and you can't factorize it easily, this is what you use to solve. So the x here is equal to t. So my t would be equal to b is negative 4. So minus, then I substitute the value of b, which is negative 4. So minus, don't forget this negative is already there. B is equal to negative. So it will be minus negative 4 plus or minus square root of b. So ideally, negative 4 squared minus 4 times a. A is 1. C is 2. All divided by 2 times a. So 2 times 1. Class, are you okay? Imelda and Co, are you fine?
Yes, please. Says this the x is equal to negative b plus or minus the root b squared, blah blah blah. Those things is another formula.
That is the quadratic equation formula. This one.
So whenever we get something like this is what we are supposed to do.
Whenever you have a quadratic equation of this form, and you can solve it easily. Some of them are easily to be factorized, but some of them too, you cannot easily factorize them. This is the formula you use.
Sir, but why didn't we multiply the 2 by the 1? Okay, wouldn't work.
So you've seen it.
Yes.
1 is still 2, that's why.
Yeah.
So t is equal to 4. My pen is misbehaving. 4 plus or minus negative 4 squared is the same as 4 squared. So 16 minus 8. Oh, meaning in the first one we made a mistake. This was 8. Let me refer to it and see where we went from. I'll come back. Oh, okay. We saw our b to be negative 2. How? Where? Okay, so this is it. 5t squared, and then and here we got 5. Which one is negative? Let me check to see where we went. Pardon? I just want to check to see where we went wrong. So 10 is equal to 20t minus 5t squared. We divided through by 5. Oh, okay. So we sent. Oh, but how would? Okay. vertically upward motion, J must be negative. And we took it as a positive in the first. So the mistake was from here. It's a vertically upward motion. So the J should have been negative, but we took it as a positive. So we made a mistake here. Class, I hope you have seen where the mistake came from.
Yes, please.
Okay, very important. So this is correct. This is divided by 2. So we have 4 plus or minus 16 minus 8. What is 16 minus 8? That's 8. Square root of 8, 2 root 2, right? Okay, 4 times 2. So 2 root 2. But give me 2 root 2 in decimal. Give me 2 root 2 in decimal.
2.828.
2.828. 828. All right, all divided by 2. So here, you consider for plus and minus. So 4 plus 2.828, all divided by 2. So we have 6.828 divided by 2. What is 6? This is 3.414 seconds. So this is one of the values, possible answers for T. The second possible answer for T would be 4 minus 2.828. And I'm doing this because it's plus or minus. So you must consider for plus and then minus. So this would also be 2. What is 4 minus 2.828? Let's do the subtraction for me. 4 minus 2.8.
1.172.
1.172 divided by 2. Yes.
Zero 0.586.
0.586 seconds. So this will be the 2 possible values of T, meaning it can take this time or this time. All right, depending on what we had as plus or minus. So for 10 meters above the ground, okay, just above the ground, this will be the value of T. Then the other question. Find the length of time the stone is above a height 10 meters if the stone is thrown from 2 meters above the ground level. So the only difference is that if the stone is thrown 2 meters above the ground level, let me refer to the first drawing. Good. It means the stone will go through a height of 8 meters. It will be here. So already we are told that it is 10 meters above. So if it was thrown from something which is 2 meters above the ground, then the vertical height the stone will go through before it attains 10 meters would be 8 meters. So that it will add to the 2 to give us the total 10 above the ground. Plus, are we okay?
Yes. So please, the first one, the second, was it the smaller one, the 0 point something?
No, we are picking T is equal to 3 points. this. I think even in the book, that's the answer they put or they took. All right. Then the second question is that the stone is thrown from something which is 2 meters above the ground. 2 meters above the ground. So there's the ground, and the person stands on something which has a height of 2 meters above the ground. And so it means before the stone reaches that height, it must go through a vertical height of 8. So H is equal to UT minus half JT squared. Now H is 8, and so the time will be 20T minus half times 10 times T squared. Please calculate this value of T for me. I'm sure this one you can easily do it. I've introduced you to the almighty formula, so do use that to determine it for me.
There.
Hello.
See, this one is vertically downward motion, right?
So both of them are vertically upwards.
Okay.
Don't forget, that's why there is minus here. This is minus. Meaning the body would decelerate. So Jesse, you have to understand how the equations, okay, were derived. In exams, they will not give it to you. You must understand, be able to memorize them to apply. You don't even need to memorize. It's a matter of just knowing that these were derived from the 3 equations of motion we have. Okay, so when you understand how the 3 equations of motion were obtained, you can easily derive these equations as well. This time around, this one is vertically upward motion. So the acceleration is due to gravity. That is why it changes from A to J in this case. And when we are going up, the body is decelerating. So J will be negative. When we are coming down, the body is accelerating. J will be positive. So spend time to go over. It's not difficult to understand and then use, okay, in exams. So this time around, when we compare our equation to a quadratic equation, ax squared plus bx plus c is equal to 0. A is equal to 5. B is equal to negative 20. And C is equal to 8. When you substitute it into the almighty quadratic equation formula, Don't forget, we are using this because we can easily solve this. If we can easily solve this, there wouldn't be any need of using this. So negative minus negative 20 plus or minus square root of negative 20 squared minus 4 times A, which is 5, C, which is 8, all divided by 2 times 5. We have T given us, oh, my marker is disturbing me. T is equal to positive 20 plus or minus square root of 400. Negative 20 squared is equal to negative 20 times negative 20. This is minus 48, 32. Are we there?
Yes, sir.
Or 20 times 8. What is 20 times 8?
160.
So 160 all divided by 10. So we have 20 plus or minus 400 minus 120, 160 is
240.
Square root of 240. Give me your answer in 3DP.
15.491. 492.
492. 2 divided by 10. So if we take the positive, we have 35.492, 35.492 divided by 10, which is equal to
354.92.
3.5492 seconds. And if we take the minus, we have 4 point something. 4 point what? Abujavu Mabre. So the answer is 0.4508 seconds. So obviously, we'll take the positive, the greater value. Let's compare. This is 3.549. Then the other one. The other one also give us 3.414. Certainly, once this is shorter, compared to when it has to. So in the first one, it is covering more distance. This is covering less distance. So that is it. That is it. I'll send you an example, 1 or 2 examples today so that this time I'll mark it for you. In fact, in the previous assignment, I've been so tight in school. The reason for which it seems to be ignored. But I'll give you an example today and then mark it for you, okay? Rempoma,
Sir, please, for the 8 meters, which seconds do you use?
come again.
The time for which the object reaches the 10 meters with the 2 meters above the ground.
Both times will do. We had a quadratic equation. So in a quadratic equation, both times would work out. Okay. So yours is to do the correct thing and then obtain the time, and that will be okay.
So say
So
how
when you are concluding, you write both of the time.
Yes.
Okay.
All right. So this is where we end today's show. Please have a nice day. Continue working hard. I'll forward your assignments to the group for you. Okay. In fact, bye-bye for today. Yeah, over my